Okay, so during the last two videos, we've been working with Tinkerbell going on her adventure or obstacle course, and I am sure that you can remember the story by now. So I'm going to tell it to you one more time, and then we're moving on to the teams, because in reality, it's not just Tinkerbell going through this obstacle course, it's actually her and all of her friends. Okay, so we know that Tinkerbell leaves the pixie dust tree, and then she doesn't have a choice whether she wants to do the first two obstacles. She has to go on the river and she has to fight the ladybug. But then there's a junction, and here with the junction, she needs to choose. Always. She can either go through the log or she can go over the log, but she must go up the tree again. And then by that time, all her pixie dust will be finished and she goes back home. Okay, so I'm going to do it with numbers one more time. And I'm not going to use Tinkerbell. I'm going to use the electron or our charge. So what we're doing now is we're taking our story and we're taking the cold hard facts of science, physics, and we're putting them both on the screen. We're overlapping them so that we can make sure that our brain understands how we're merging the story and the facts. Okay, so our little charge, our little electron leaves the battery, and let's say it leaves with 100 joules. Now, when the obstacles are in series, meaning when it moves down the connective wire and it gets to a resistor, an obstacle, it doesn't have a choice. It has to go through. So let's say it uses 10 joules going through the first resistor and 30 joules going through the next one, and let's make this one 20 joules. Okay, so if we look at the resistors in series, then we have resistor number 1, we have resistor number 2. This whole parallel circuit will be resistor number 3. We'll get back to number 3, and this is number 4. So if we take 1, 2, and 4, and we add those joules up, the energy it needs up, we will get to 10 plus 30 is 40, plus 20 is 60. Which means that going through this third resistor, either the first path or the second path, it will require 40 joules. Okay. So if we follow our little electron, it starts with 100 joules, it goes through the connective wire. Here it uses 10 joules, so now we have 90 joules left. It goes through the wire, it doesn't use any energy. Then it uses 30 joules going through the second resistor. So now we have 60 joules left. Okay, and now our little electron can choose, will it go up or will it go down? It doesn't matter because it's going to use 40 joules in any way, which means we have 20 joules left. And then going through resistor number 4, it'll use all 20 joules. And now all the energy is used up, and it has to go back to the battery to get some new energy, pixie dust. So we start with 100, then it becomes 90, then it becomes 60, then it becomes 20, irrespective of which path it takes, and then it becomes 0, and when it's 0, it needs to go back. So now we're going to switch over a little bit and we're going to look at the teams. So in reality, it's not just Tinkerbell going on this adventure on her own. It is Tinkerbell and all of her friends. Okay, in science, it's not just one electron moving out of the battery and through the circuit and back in. It's a continuous supply of electrons. So we've looked at what happens to the energy of each electron, and that is the same as what happens to the voltages. We'll get to that in the next video. Now we are going to look at the teams going through, or the current. So the path is still the same. The idea is still the same. Now we are going to zoom in on each of the team members. And we are going to be working with 5 fairies. Okay, so these are the 5 fairies that is going through our obstacle course. Okay, now I wish I had time to make this an animation. But if we look at Periwinkle, Periwinkle will go through the first obstacle, through the second obstacle, and here she will have a choice. Let's say she goes through the log. Okay, then Rosetta will do the same. She'll go onto the boat, she will battle the ladybug, and here she will decide, I'm rather going to go over. Okay, she's too stylish to go through the log. Then we have Vaughn, same story. She goes onto the river, she fights the ladybug. They don't have a choice because it's in series. And here she will join Periwinkle. Iridessa will go through the first resistor, the second resistor, and let's say she joins Rosetta at the bottom. And then we have Terence going through the first one, going through the second one, and let's say he goes with the 2 at the top through the log. Okay, so if we change this over into science speak, the team will be your I value, your current, and it is measured in amperes. So because we have 5 fairies, we have 5 amperes. Okay, so we have 5 fairies coming out of the pixie dust tree. We have 5 fairies going through the first resistor. We have 5 fairies going through the second resistor. And now there's a junction and they have to choose. Okay, so we have 3 fairies going through the top one and we have 2 fairies going through the bottom one. But when they come out, there's still 5 fairies. Okay, we didn't lose a fairy along the way. It's not possible, not in electric circuits. Okay, so do you see what happens to the ampere values, the current? The current always splits up into the 2 paths or 3 paths if you have 3 paths. And the way they split up, and it should sort of make sense to you, the more difficult one, the more difficult obstacle will have less fairies. And the easier one will have more fairies. Okay, so there's a relationship between the current and the resistance, and we'll get to that in the next video when we look at the cold hard facts of circuits. But for now, I just want you to see that when we look at the team of fairies, that's our amperes, our current. Okay, so this is part 1, it's a team, and then the team we change into current, that's part 3. We'll look at the checklist now. Okay, so we have a team of 5 fairies. All 5 fairies need to go through obstacle 1. All 5 will go through obstacle 2. But when there's a junction, they will choose. The easiest obstacle will have the most fairies go through, and the more difficult one will have less fairies. But when they come out on the other side of the parallel circuit, all 5 will be back together. They will be a team again, and then they will continue back to the battery. Okay, so now in this video, I didn't have a clear part 1, part 2, and part 3. I sort of mixed them all together because I think you have a solid understanding of what the story entails. Okay, so I'm doing it a little bit faster than in the first video because we have more resources, we have more skills. So if we look at the teams, that's part 1, we know that the number of fairies going into the race will be the same as the number of fairies coming out. We're not going to lose fairies along the way. The whole team will pass through every obstacle. However, at junctions, they can only pass through one path. The team will split up. Okay, and to save time, more fairies will pass through the easier path. So it's exactly what I just told you. So if you haven't written it down yet, please write it down. And then, so pause the video and write it down. And then when you're done writing it down, you can press play again. And then we're going to switch over the fairy tale terms over to science. Okay, so if we look at the number of fairies, that's our team, right? But the fancy word is current. The symbol is I, and it is measured in amperes. Okay, so it's just for a note for now. In the next video, I will give you all the information clear and simple. So the current going into the circuit will be the same as the current coming out, which means the current remains constant throughout the circuit. So the whole team, let's make it all current, will pass through every resistor. But now there's a T's and C's. However, at junctions, let's make that parallel parts. They can only pass through one path. The current will split. And to save time, more current will pass through the resistor with least resistance. So now if you want to copy it one more time, and I strongly suggest that you do, this is part 3. So the current going into the circuit will be the same as the current coming out. So the current is being conserved. It will remain constant throughout. The current will pass through every resistor. However, at parallel paths, the current can only pass through one path, so the current will split up. And to save time, more current will pass through the lower resistor. So the resistor with a lower resistance. And that is the end of our story. Okay, so this is the theory. In the next video, I am just going to revisit the specific terms so that you have the scientific terms and the scientific definitions to work with. And then I'm going to show you how we're going to do the sums. Now, the sums are really easy if you do it in a structured, proper way, and it actually gets quite fun.